was Pythagoras, and what did he contribute to geometry?
Explain how geometry is used in your everyday life.
The word geometry comes from two Greek words, geo, which means the earth, and metron, which means to measure. Today, geometry is more the study of shapes than it is the study of the earth. Basically, geometry is the branch of mathematics that deals with the position, the size, and the shape of figures.
One of the greatest mathematicians was an ancient Greek named Pythagoras. He discovered some of the most important mathematical concepts that came to be called geometry.
One observation he made was that gravity is vertical, or 90 degrees to the horizon. From this observation, Pythagoras discovered that the 90-degree angles from 4 right-sided triangles make up a square. Watch this. If I have one right angle, and I place 3 other right angles around it, like this, I eventually wind up with, ta-da, a square. That's pretty neat. Let's do the math. Knowing what Pythagoras discovered about the right angle, can you calculate how many degrees are in this square? If you multiplied 90 degrees times 4, you're right. This square has 360 degrees. What other shape has 360 degrees?
A circle. You know, Pythagoras proved that there are relationships between different geometric shapes. What relationships can you see between other geometric shapes?
Get this. Pythagoras found out even more laws about the right triangle. If we look at the same square, but just a little differently, we can see that half the area of this square equals a right triangle. Now, how can we use math to calculate the remaining angles of a right triangle? Simple. Squares are 360 degrees, we know this. If we divide it in half, this triangle must equal 180 degrees. Now, we know this is a right triangle. This equals 90 degrees. If we subtract that from 180, we get 90 degrees. These two angles must add up to 90 degrees. This is true for every right triangle. It's true for this right triangle. It's true for this right triangle. And it's even true for right triangles that look like this. In order to calculate the remaining angles of a right triangle, you have to use math and geometry.
Geometry is used in everything we do, from constructing roads and buildings to playing football or pool. Okay, here's the big play. It's you and me, okay? I'll toss the big pass to you, you go down and out. Got it? Got it! Great! Now, let's see. If I toss the ball directly to Jennifer and don't anticipate where she'll be, I'll miss her completely. However, if I know she's cutting right and I throw the ball at the correct angle, I should get the ball to her. Hey! My perfect pass just created a right triangle. Geometry is everywhere.
Hey, way to go, man! Without geometry, it would be impossible to organize precise patterns and play a simple game of football. My friend Lynn Chappell is an 8th grade math teacher at Huntington Middle School in Newport News, Virginia. Let's see what information she has about Pythagoras and geometry.
The most important discovery that Pythagoras made was the relationship between the longest side of a right triangle and the two shorter sides. The longest side of the right triangle is called the hypotenuse. Now remember, the Pythagoras' theorem is a squared plus b squared equals c squared.
Now, who could tell me what that means? Charmaine.
The sum of the squares of the two shorter sides, a plus b, equals the square of the longest side, c, which is the hypotenuse.
Good answer. Now we're going to mark the right triangle that we have on this paper, and the shorter sides, also called the legs, are a, and B. And the longest side is C. And remember, we call that the hypotenuse. Now what Pythagoras did was draw a square on the side of A. And remember that a square is a number times itself, A times A. And he drew a square on the side of B, B times B, and he drew a square on the side of C, C times C. But what we're going to do is we're going to cut A squared off of the side, and then we're going to cut B squared and make them fit into C squared to prove that Pythagoras was right. First, take your straight edge, and we're going to draw some parts of B so that we can cut it and it will fit. Coming along the side of C, come straight down through B squared till you touch the edge. Now connect the lower corner of B to the bottom edge of A squared. This will form a perpendicular line. Now take your scissors and cut out A squared in one piece and B squared in the pieces that you've cut it into. And then we'll fit it all onto C squared to prove that Pythagoras was right. Well, have all of you fit your pieces together? Yes. Then I guess Pythagoras was right.
And you know, Pythagoras also believed or postulated that the shortest distance between 2 points is a straight line.
Well, how come if you throw a ball from point A to point B, then it curves or arcs?
Well, Van, that's rather very simple. Ever heard of something called gravity?
Yeah, I heard of gravity! In 1600, Johannes Kepler, a famous astronomer, proved that the planets orbited the sun in an ellipse. That's another geometric shape. If you take a circle and squash it a bit, you get an ellipse. Like our football example, if we want to navigate from Earth to Mars, we have to take into account where Mars will be within its elliptical orbit.
What information did scientists first discover about Mars?
Humans have known of Mars since before recorded history. In 1609, a man by the name of Galileo first viewed Mars through his newly invented telescope. Although his telescope was no better than a modern toy, it revealed enough to prove that Mars was a large sphere, a world shaped like the Earth. Could this other world be inhabited?
Besides using the telescope, how else did scientists collect information on Mars?
Let me tell you, NASA's Mariner 4 was the first spacecraft to take close-up pictures of the red planet.
As it flew past Mars in 1965, it showed a heavily cratered surface. 6 years later, in 1971, Mariner 9 arrived at Mars and became the first artificial object ever to orbit another planet. Mariner 9 saw the Valles Marineris, a canyon that stretches 4,500 kilometers, or 2,800 miles, across the face of Mars. It is so long that, if it were on Earth, it would stretch all the way from Los Angeles, California to New York, New York.
All these discoveries by Mariner were seen from above the surface of Mars. What we really needed was a view from the Martian surface.